can survive for sustained periods of time and temperatures above body temperature. The body is able to deal with these higher temperatures by releasing sweat, which upon evaporation releases heat energy from the skin. Which of the following would prevent human survival only if the ambient temperature is near or above 37 degrees Celsius? A. The relative humidity of the air reaches 100%. B. Dehydration. C. Lack of access to a breeze or other air current. And D. Inability to perspire. This is a difficulty 4 question. Okay, so yes, this is intimidating. It is a relatively difficult question, and this is one of those questions where you really have to understand what they're asking. Okay, first we see a reference on body temperature, and we should already know this, but if you don't, 37 degrees Celsius is the temperature at which the body is regulated. Okay, and the question is you're asking, which of the following would prevent human survival only if the ambient temperature is near or above 37 degrees C? And right away, reading through these questions, I'm looking at dehydration. Oh yeah, I can easily just circle this and move on to the next question. Or inability to perspire. Yeah, if I don't perspire, I'm probably gonna die. But this is asking, which one of these would prevent human survival only if the ambient temperature is near or above 37 degrees Celsius. So in all other cases, right, it's saying that there's something that is going to change when it's this temperature. Okay, so if I made a little bit of a I don't know, I can make a little bit of a graph here on the side if I want to. And I can say, okay, well, at temperatures that are less than 37 degrees and temperatures that are, put a little T there for temperature, and temperatures that are greater than 37 degrees Celsius, what's going to happen? Is there anything that's going to change? Okay, so let's start on the bottom here. Inability to perspire. Okay, if I can't perspire, if I can't get rid of sweat, then I'm going to die, right? It doesn't matter what the temperature is. Either way, I'm gonna die if I can't perspire. I'm not gonna be able to cool myself down. What about lack of access to a breeze or other air current? Okay, well, same thing. The temperature is not really going to change anything. It's going to be the same situation. What about dehydration? Well, yeah, if I'm dehydrated, obviously, if the higher the temperature, the quicker my death might be. But in all of these cases, I know that it's not any of these three, so I know it must be the relative humidity of the air. And let me explain to you why it's that. And let me explain why, if you're good at chemistry, you can come quick to this answer much more quickly than I just did using this graph here. And this is actually the way that I came to the answer. Think about if you live in Arizona, okay, where the humidity is really low in the air. It's really easy to sweat, but then to cool down, because when you sweat in Arizona, if this is your skin, a lot of these molecules that you have on your skin, the sweat is going to easily break through that pressure, and it's going to turn into a gas particle. And every once in a while you might have a particle in the air that'll land here, but you have so many more particles going into the air that your body is able to cool down much quicker. If you live in Florida, especially like Miami, where the humidity is much higher, if this is your skin, in this case, you're not going to get quite as many particles, right? You're going to get maybe one or two of these guys that come off, but then you're going to get another particle in the air, maybe two more particles in the air that land on your skin. So you're not going to be able to cool off as quickly. You're always basically going to be sweating because you're going to have a higher humidity here in Florida, higher humidity. Okay, and some of us that have lived in these places know what we're talking about. So now let's just think about it in terms of your body. So now let's go back to this temperature. If we're talking about, if we say 37 degrees C, we have a temperature that is less than 37 degrees C, right? Temperature that's less than 37 degrees C. Well, what's going to happen? Well, on our skin, even though the humidity is 100%, right? That's what the question said. The humidity is 100%. We're still going to have some molecules that leave our skin because our body's regulating a warmer temperature. So yes, it might be tough for these molecules to leave our skin, but there's still going to be some leaving. And so, if you had your skin and you had the molecules that are going into the air, molecules, air, right? This is just an oversimplification, but this reaction is going to still lean towards the right, right? Because you're going to have more molecules leaving and going into the air. But if the temperature, this is the key component, when the temperature is greater than 37 degrees, greater than or equal to 37 degrees Celsius, well, if it was equal to 37 degrees Celsius, like it says in our question, now what's going to happen is these particles, because you have 100% humidity, these particles are going to be in equilibrium with the sweat on your skin. So they're not going to be able, so in this case, these are going to be in equilibrium, 100%, and the reaction is going to lie dead center here in the equilibrium in terms of the molecules leaving and remaining on your skin. So because of that, you will not be able to cool down. So I know you don't have that much time on MCAT to go through what we just went through, but that's why you have to really understand it. And if you understand it, I think anybody with a strong background in chemistry would be able to see that this is the answer right away. Although you'd be surprised, most people, when I say most, I would say that, and I don't usually put this on here, but I would say out of everybody that takes the MCAT, I would say about 75% get this question wrong, and about 25% would get it right. So it is a tough question because there's a lot of easy picks here, but these are all very misleading when you actually read into the question the way that you're supposed to.